Hello, grade 10. How are you today? I hope you're doing fine. So today we are going to continue talking about static electricity, okay? To be more specific, we're going to talk about Coulomb's law. So we're going to do some calculations, but don't freak out. We're going to go slowly, but please pay attention, okay, to understand all the steps that we are following. But before, let's understand what's Coulomb's law, okay? Coulomb's law came from a guy who that name was Charles Auguste Coulomb. What this guy did, he took two particles that were electrically charged, and he measured how much this charge, the forces that keep this charge together, if they are attracted to each other, or how much they are repelling each other. So he measured this force, okay? And then he made a conclusion that the magnitude of this force, or how much force is going to attract or repelling a charge, depends on two factors. So depends on two main factors. Their charge. So if I have more charge in my particle, I'm going to have more force of attraction. So they are directly related. So if I have more charge, so if my charge is higher, the higher is my charge, the higher is the electrical force that keeps the charges together or repelling. Okay, so if the charges are the same signal, they're gonna repelling. If the charges are the opposite signs, they are gonna attracting. So if you're not familiar with this, please come back to the previous videos where I explain this force of attraction of repulsion. Okay, in this video I'm focus just in Coulomb's law. Okay, so the force of attraction or repulsion depends on the charge. So the higher the charge, higher is this force, and also depend on the distance that separate them. So if I have two charges that is very, very far away from each other, do you think the force of attraction or repulsion of them is going to be higher or lower? What do you think? Think for a moment. I have two charges. They are very distant from each other. They are going to have a strong force attract or repelling them, or this force is going to be weaker than if they were very close. What do you think? Yes, so this force is going to be weaker. So the higher the distance, the lower the electrical force. So again, for the charge, the magnitude of the charge is directly related to electrical force. So the higher the charge, the higher the electrical force. And the distance is inversely proportional. So the higher the distance, the lower the electrical force. Okay? Is that clear so far? Okay. So, in summary, the magnitude of the force between two immobile and electrically charged particles is directly related to their charge. So, the force is directly related to the charge and inversely proportional to the square of the distance between them. So, the electrical force, if the electrical force is higher, it means my charge is also higher because it's directed, and my distance is inverse. So it's going to be inverse proportional to more distance. Putting everything of this, putting all these three variables together, he formulates one formula. His formula is this one. The electrical force, that is Fe, is equal to K is just a constant, times the charge of the first particle times the force of the second particle, divide everything by the square of the distance that he represents here by R. So Fe is electrical force. How do we measure force? It's the same as we were studying before, by Newton, sorry. So force we measure by Newton. And then there is a convention, okay? When we are doing the exercise, if the force are of attraction, if I'm dealing with two opposite charges, I need to put my force with a negative sign. And if it's repulsion, I need to put a positive sign, okay? This is just convention, okay? Now, Q1 is just the charge of the first particle. If I'm talking about charge, how do I measure charge? I'm measuring Coulomb. So we talked about this in the previous video. So charge, we measure in Coulomb. Q2 is the same. So charge again, I also measure in Coulomb. R is the distance, and the unit that we are going to use here is meter. Okay, so if it's not in meter, we need to convert. And finally, the K is the constant. So it's a number that he calculates. So constant, look, Coulomb's constant. So it's a constant that he figured out. It's going to be constant. It's going to be given for you. Okay, you don't need to worry. You just need to plug in this number in the formula. And as you can see here, these constants can show you all the units. So if you are not, you are not sure about the units, if you look to the constant, you're gonna find all the units. So N is gonna be what? Newton. M, meter, and C, Coulomb. So you need to check your units if it's according to this constant. Okay, so these constants help you to figure out if the units are okay before you started your exercise. Okay, so let's do some exercise using this formula. Example 1. Suppose that 2-point charges, each with a charge of 1 coulomb, are separated by a distance of 1 meter. Determine the magnitude of the electrical force of repulsion between them. Okay, so always when you're doing an exercise, just read one time, okay, just like I did. The second time, read again. And then the second time, highlight the main units you were talking about, and the main variables you're talking about. So I'm gonna read again slowly, but point out the units that I have, the variables that I have. Okay, suppose that 2-point charge, so I talk about 2 charges here, each with a charge of 1 coulomb. It means that each of my charge has 1 coulomb. So I have 2 charges that have the same magnitude. So both of them has 1 coulomb. And they are separated by a distance of 1 meter. Okay? So here I have the charge, that's 1 coulomb, and the distance is 1 meter. Now what is asking you? Determine the magnitude of electrical force. So he's asking you the force, the electrical force of repulsion between them. Why is repulsion? Because they have the same charges. So it's repulsion because they have two, each of them has positive charge. If both of them has positive charge, it means they are gonna repel each other. So of course, my force is gonna be repulsion. And according to the convention that I told you before, if it's repulsion, my force is gonna have a positive sign. Okay? Okay, so now I read 2 times. Now I go to my first step. What's gonna be my first step? And this you can use for any kind of problem, okay? Not just in chemistry, but any kind of problem. Step 1, make a list. This is gonna help you a lot. Because here I'm talking about this formula, okay, Coulombs law. I'm gonna make a list according to this formula. So according to this formula, I need to find Fe, K, Q1, Q2, and R. So what do we have? According to my problem here, I have already the charge, and they said both charges are the same. So I have Q1 is 1 coulomb, and Q2 also 1 coulomb because it was told me in the problem. What else do I have here? I have the distance of 1 meter. So I have the distance that I put as r as 1 meter. And k is not given, but it's gonna be given to you, okay, don't worry. But it's constant, it's gonna be always this number, 9 times 10 to the power of 9 newtons meter squared to the coulomb square, okay? So this is the first step. And now I need to figure out what I need to find. I need to find the electrical force. If I need to find this electrical force, I'm gonna put a question mark here because that's something I need to find, okay? So that's your first step, make a list. Is that okay? Now, second step. Second step, you always need to check the units. So check the units of your problem. And a good tip for you to not forget the units is looking for your constant. So for example, your charge is in Coulomb, right? Checking the constant. Constant, you also have Coulomb, so it means they are in the conventional unit. What about distance? Distance is in meter, and here is also in meter, so they are fine. I don't need to convert anything. And then I ask you, when I calculate, when I find my force, what's gonna be the unit of my force? It's gonna be Newton, yeah? So if you remember the previous classes, you know that force we usually measure in Newton, but if you don't, you also can look here. So this N is N for Newton for the unit of force. So here is everything fine. I don't need to convert anything, but if I had to convert, I need to convert before the next step, okay? Now, next step, step 3, replace in the formula. So I'm gonna write down again my formula here. I'm just gonna plug in my numbers. So force, I don't know. K is 9, so my K is 9 times 10 to the power of 9, okay? It's given. My Q1 is 1 Coulomb, so I put 1. My Q2 is also 1. My R is also 1, so this one is an easy one, to the power of 2. Okay? Any problem so far? I guess not, right? So let's move on. What's going to be the step 4? The step 4, we just need to simplify my formula. So let's multiply. Everything is possible. So 9 times 1 times 1, what do I get? 9. 10 to the power of 9, I just have 10 to the power of 9, just copy. And 1 to the power of 2 is 1. Okay? And continue until I simplify as much as possible. Now what I can do? I can divide this 9 by 1. So 9 divided by 1 is 9. 9 times 10 to the power of 9. What I just found? 9 times 10 to the power of 9 newtons. I just found my electrical force. Okay, so this one, the math was pretty easy. I just want you to understand the steps very well, okay? But not always the numbers will be so much easier. So let's do some a little bit more complicated, but the steps will be the same. The only complication is a little bit of math, okay? Okay, take a breath and let's go. Example 2. So as I told you, I'm just gonna read one time. Then the second reading, I'm gonna highlight. So example 2. 2 balloons are charged with an identical quantity and type of charge, minus 6.25 times 10 to the power minus 9 Coulomb. They are held apart at a separation distance of 61.7 centimeters. Determine the magnitude of electrical force of repulsion between them. Okay, I read one more time just to have an idea of the problem. Now what I'm gonna do? I'm gonna highlight the main variables it was given. So 2 balloons are charged with an identical quantity and type of charge. So what it was given here? The charge. So they said the 2 identical charge. So both charges has the same. Minus 6 times 2.5 times 10 to the power of 9 minus 9 Coulomb. So now I have my charge. They are held apart at a separation distance of 61.7 centimeters. So it gave me the distance. Okay. And what is asking me? Determine the magnitude of electrical force of repulsion. So, electrical force of repulsion. So, it's asking me the force of repulsion, the electrical force. Okay, if you remember from the previous example, what's the step 1? Step 1, list. Always, okay? Make a list according to my formula. So, let's write down my formula. So, electrical force is equals K times Q1 times Q2 divided by R2. What do I have from the problem? Q1 is minus 6.25 times 10 to the power minus 9, and they are identical. So my Q2 is exactly the same, it's identical, minus 6.25 times 10 to the power minus 9 Coulomb. What else do I have? The distance, 61.7 centimeters. What else is not written, but I always have this information, is the constant, 9.10 to the power of 9 newtons per meter square divided by Coulomb square. Okay? Step 1, done. My list. No, not done, sorry. And what I need to find? My electrical force. And then my electrical force will be positive because it's repulsion, remember the convention. And it's going to be in Newton when I find it. Now, what's the second step? The second step is check the units. So let's check the units. Here, I have my charge in Coulomb. Is it okay? Yes, so my charges are fine. Are in Coulomb. It's the same as the constant. What else do I have? My distance in centimeters. Is this fine? No, should be in meter. So what I'm gonna do? I'm gonna convert it. So if my distance is in centimeters, I need to convert to meter. So my distance will be 0.617 meters, okay? Really important. So please be careful when you are doing this exercise. Is there anything else I need to look? No. So let's go to the step 3. Step 3, replacing the formula. So I'm gonna write down the formula again, and I'm gonna replace. Here, my constant is 9.10 to the power of 9. My first charge, minus 6.5 times 10 to the power of minus 9. My second charge, minus 6.25 times 10 to the power of 9, because they are identical. Just look to your list. And my distance that I just convert here, 0.617 to the power of 2. Okay? So I just replace in the formula, nothing new here. Next step, simplify and calculate. So how I can simplify here? The easiest way is for you to look for the numbers that is not the 10 to the power of something. Okay, for example, 9 minus 6.25 and minus 6.25. And multiply them first. So 9 times minus 6.25 times minus 6.25. Be careful with the signals because this is minus and minus, so it's going to be plus. I'm going to have, if you do in your calculator, you can check, 351.6, okay? What about the tens? What I do? So I have 10 to the power of 9, 10 to the power of minus 9, 10 to the power of minus 9 again. What's the rule when I have the exponents like that? I keep my base, in this case 10, and I add my exponent because I'm doing a multiplication. So I have 9 here plus minus 9 is 0, right? 0 plus minus 9, I get minus 9. Okay? Now the last one below, 0.617 to the power of 2. So if you do in your calculator to check, it's going to be 0.38. It's not done yet, okay? We can simplify more. How? I can divide 351.6 divided by 0.38. So I get 925.3 times 10 to the power of 9 minus 9. But remember, in the scientific notation, I always keep my number with just below 1 and 9. So I'm going to put in scientific notation. So 9.2, I'm going to put a new color here. So 9.2 times 10 to the power of minus 7. So according to the rule, I decrease my number here. So I need to increase my exponent. In this case, my exponent is negative. So if I increase, it's going to be minus 7. Okay, so this is a completely new, not new, but it's another subject. I'm not going to explain this rule here. This is just math rule. Okay, so keep this in scientific notation. Okay, so come back to your question. Determine the magnitude of the electrical force of repulsion between them. What's going to be my electrical force? 9.2 times 10 to the power of minus 7 Newton. Okay? Okay? Okay, let's go to the next one. Example 3. Two balloons with charges of positive 3.37 times 10 to the power of minus 6 and minus 8.21 times 10 to the power of minus 6 attract each other with a force of 0.0626 Newton. Determine the separation distance between the two balloons. Okay, I read one time. Now, what I'm gonna do? Read again and highlight the variables it was given. So two balloons with a charge of 3.37 times 10 to the power of minus 6 and minus 821 times 10 to the power of minus 6. So I don't have identical charges. I have two different charges now. They attract. Why they attract? Because they are opposite. With a force of 0.0626 Newton. So now I have a force. So I have charge here and force here. And what is asking me? Determine the separation distance. So it's asking me the distance now, not the force. Okay, so be careful what it's asking you. So it's asking you the distance. Okay, first step. What's the first step? Tell me. So I can hear you. Go. Yes. So step 1, a list. Make me a list. What list? Remember the formula? What's going to be the list? So here I have two different charts. So my Q1 doesn't matter which one you put as 1, which one you put as 2, okay? That's fine. If you put this one as 2, that's also fine. So Q1 for positive 3.37 times 10 to the power of 6 Coulomb. Q2 minus 8.21 times 10 to the power of minus 6, also Coulomb. And I have my distance? No, that's what I'm looking for. So I'm going to put a question mark. But I have my constant, is always given, and my electrical force. Now, I ask you, why here is negative? Why I put as a negative here? Why? Because by convention, if it's attraction, force of attraction, I put the force as negative, okay? So this is just convention. If its force is attraction, I put my force as negative. Okay, now what's the step 2? Step 2, check the units. So let's check the units. My force here, my charge is in Coulomb. It's okay? It's in Coulomb? Yes, it's fine. My force is in Newton. It's fine? Yes. So I don't need to convert anything. And when I calculate my distance, it's gonna be automatically in meter. So I check, I don't need to do any conversion. Okay. So step 3, replace. So let's write down the formula and replace it. Now I have my force. So my force is here, minus 0.0626. So be careful with this negative, okay? And my K, 9.10 to the power of 9. My Q1, 3.37 times 10 to the power of 6. I put positive because it was positive. My Q2, minus 8.21 times 10 to the power of minus 6. And my distance that I don't know. So I just copy there. I don't know yet. Okay? So I just replace. That's it. I put in parentheses because now I have a lot of signals. So for me to not do any mistake, I recommend you to put in parentheses too. Okay? Step 4. Let's simplify. How we can simplify? What's the first step we can do? I guess the easiest way is for you to do cross multiplication because this one is going to be over 1. So you can do cross multiplication like that. 0.026 times r to the power of 2 and 1 times everything else. So 0.0626 times r2, I just put here, and then I copy everything else. What's the second thing I can do? I can just multiply my numbers. Okay, that's not exponent. So 9 times 3.37 times minus 8.21. And I just copy the first part. So 9 times 3.37 times minus 8.21, I'm going to have minus 2.249. Now, what about the exponent? So I have 10 to the power of 9, 10 to the power of minus 6, and 10 to the power of minus 6. If I add all of them, because I'm multiplying, 9 times minus 6, it's going to be 3. 3 minus 6 is minus 3. So 10 to the power of minus 3. Now, what I can do, this one is multiplying, I'm putting below to divide. So minus 2.249 times 10 to the power of minus 3 divided by minus 0.0626. Why it's negative? Why it's not positive here? Because I'm not, what the inversion I'm doing is from multiplication to division. So I don't change the signal. It goes with this signal. Now, what I need to do? I need to divide minus 249 divided by minus 0.0626. So dividing minus with minus plus 2.49 divided by 0.0626, I get 3,977.63 times 10 to the power of 3. I didn't change anything else. But now I can change to have a scientific notation. So I'm gonna, if I do this point 1, 2, 3 times, I'm gonna get 3.977. And if I increase here 3 times, I'm gonna have 10 to the power of 0. It's gonna be 1. So 3.977. But it's not done yet because this one was square root. So when I do square root here, I get 1.99 meters. Okay? I know this is a little bit more complicated, but it's basically math. Okay? It's not Coulombs at all. If you are not so sure about this, please you need to study a little bit more of math. Okay? So my distance here is 1.99 meters. Okay, let's go. Okay, so let's do one more. Okay, last one. Example 4. Two positively charged bodies, each with a charge of 5 times 10 to the power of minus 8 coulomb, are placed 1 centimeter apart. What will be the electrical force between these two bodies? So first step, no, not first step, sorry. We just read. Now what we're gonna do? Highlight. So I have two positively charged bodies with a charge of 5 times 10 to the power of minus 8. So both of them has the same charge. I placed 1 centimeter apart. So there, this is the distance. What will gonna be the electrical force between them? What's gonna be the electrical force? Now let's go do a list. So our list, again the formula. I have my first charge, 5 times 10 to the power of minus 8. My second charge is the same, so 5 times 10 to the power of minus 8. My distance, 1 centimeter. And my constant, always the same, 9.9 times 10 to the power of 9. And I need to find my electrical force. Second step, check the units. So my coulomb here is my charge, coulomb, my other charge, coulomb, and my constant, also coulomb, so it's fine. What about my distance? I have here 1 centimeter. It's fine? No, should be in meters, so I need to convert. So 1 centimeter is going to be 0.01 meter. Third step, I need to replace. I'm going to write down the formula again. I'm going to replace it. So my force, I don't know. My constant, 9 times 10 to the power of 9. My first charge, 5 times 10 to the power of 8. My second charge, 5 times 10 to the power of 8, because they're the same. My distance, 0.01 meter. Be careful, okay? After you convert, you put the value of the conversion, not the centimeter. Now the last step, simplify and calculate. So here I have my formula, very complicated. What I'm gonna do first, my advice for you, just multiply this number first. So 9 times 5 times 5, I'm gonna be 225, and my exponent, 10 to the power of 9, 10 to the power of 9, and 10 to the power minus 8, and 10 to the power of minus 8. I keep my 10 and I add my exponent. So 9 plus minus 8 plus minus 8. It's here. 9 minus 8 minus 8. And below 0.01 is to the square of 2, 0.0001. I'm gonna simplify my exponent here, so I keep 225 times 10 to the power of minus 7. So 9 minus 8, 1. 1 minus 8, minus 7. And then below, I'm converting to the power of 10, okay? But if you wanna do another way, that's fine. So 0.0001 is equal to 1 times 10 to the power of minus 4. What I'm gonna do now, I'm gonna divide these two power of 10 here. So it's gonna be 225 divided by 1 is 225. 10 to the power of minus 7 divided by 10 to the power of minus 9 is gonna be 10 to the power of minus 7 minus minus 4 because it's a division. So I'm gonna have 225 times 10 to the power of 3 minus 3, so minus 7 minus minus 4 is plus 4. So minus 7 plus 4 minus 3. And now I'm gonna just convert to scientific notation. 225 times 10 to the power of 3 minus 3. I'm gonna decrease here, so I'm gonna increase the exponent. So 2.25 times 10 to the power of minus 1. Okay, thank you so much, guys. I hope this helped you a lot. Okay, and please do the exercise in the form below. Okay, thank you so much.